Therefore, the pole in the S-plane from the transfer function GS are located at 2n equally spaced points around a circle of radius omega c. However, we select only those on the left-hand side of the S-plane will give the pole at point n, where n is from 0 until n minus 1 is equal to omega c multiplied with exponent jn plus 1 plus 2n multiply with pi divided by 2n, where this function is actually equal to the magnitude of omega c with the phase n plus 1 plus 2n multiply with pi divided by 2n. In designing the Butterworth filter, the first three steps required is, the first one is to determine the discrimination factor D. The second one is to calculate the selectivity factor K, and the third one is to determine the filter order N. The fourth one is to compute the 3 dB cutoff frequency omega c to any value within the range. So the omega c is larger and equal than omega p, the passband omega, multiplied with epsilon with the power of -1 divided by 2n, and also omega c is smaller and equal than omega s, the stopband omega, multiplied with a squared minus 1 with the power of -1 divided by 2n. This epsilon is actually equal to 1 minus delta p, the passband ripple deviation, with the power of -2. While this a squared is actually equal to delta s, the stopband ripple deviation, with the power of -2. And then this function is also equal to this one based on the attenuation passband function, and this function is actually equal to this one that based on the stopband attenuation. The next one is to determine the left-hand side poles based on this equation as described in previous slides, where we have this function. The next step is to synthesize the system function, where HAS, the frequency in S domain, is equal to the production with the limit n from 0 until n minus 1 for left-hand side for the function of omega c with the power of n divided by s minus pn, the pole at point n. If we have 3n, in this case from 0 n equal to 0 until 2, we have 3 pole, then meaning that we need to repeat this function for 3 times s minus the first pole, multiply with s minus the second pole, and multiply with s minus the third pole. And finally, we proceed with the digital and frequency transformation from S domain to Z domain to frequency domain.